talk, Computers Gone Rogue. I'm Marina. I'm here today with Itai, also known as the guy with the crazy hair. And today, we both are security researchers at Microsoft in the ATA group. And today, we're here to talk to you about how computer accounts can be abused by attackers in different attack stages in an Active Directory environment. Let's begin with a short motivation to our talk. Why have we decided to discuss this issue? So we all know that attackers love credentials. Why search for sophisticated zero-day exploits when you can simply use what is present on any domain machine, credentials, and just use them to spread in the network and compromise more machines? So the main focus for attackers is usually user and service accounts. Those are the accounts that hold the highest privileges in the environment. So for obvious reasons, attackers prefer to target those and get administrative access to as many domain resources as possible. However, there's another type of account which gets the least amount of attention. And I'm talking about computer accounts. So you might ask yourself, can a significant damage be caused to my environment using those computer accounts, since they barely have any privileges in the environment? Also, am I currently monitoring them properly, and how exactly should I be monitoring? So those are exactly the questions that we're hoping to answer here in this talk today. So we don't have a lot of time. What are we going to discuss today? We're going to see how those computer accounts can be abused in different attack stages, starting from the reconnaissance phase, moving on to the lateral movement phase, and finishing with the persistence. Then we're going to see a demo to illustrate each and every one of the attack techniques, and finally discuss some mitigations. All right, so before diving into each of the attack stages, let's just briefly discuss the common stages to almost every attack that we see today. So attackers start by infiltrating the network by compromising some domain account, for example, by sending a phishing email. And usually, they don't initially land on the computer which contains the interesting data. So they need to figure out how to get from that initial machine to their target. So this is where the reconnaissance process begins. They start to figure out the structure of the network, who are the users, the computers, the groups in the environment, who are those high privileged users. And once they have all that information mapped out, they can start moving laterally in the network. So they move from one machine to the next, each time dumping more credentials, using them to connect to more domain machines, and so on until finally compromising the credential of some domain administrative account. However, usually the attack doesn't stop there, and once attackers have those high privileged credentials, they would like to ensure that they also have full persistence of the environment. So why is a domain admin account not enough to gain persistence? Well, what happens if someone changes the password of that account? So attackers would lose a hold of the environment and would have to find another high privileged accounts to compromise. This is why once they have that domain administrative account, they want to ensure that they would have those high privileges for as long as possible without being detected. So there are a lot of known techniques that abuse user accounts in each and every one of those stages, but today specifically we're going to talk about computer accounts and show how they can be abused in each and every one of the attack phases, starting from how to compromise that initial domain computer, how it can be used to move laterally in the network, and finally, how it can be used to gain full persistence in the environment while avoiding detection. So at this stage, Itai will begin by discussing the first two phases.
Thank you, Marina. Hi. So now we'll show you how attackers can use or abuse computer accounts in different phases of the attack kill chain. So in the first phase, which is the recon phase, the attacker's goal would be to acquire or compromise at least one computer account. And for that, they have several options. Either they compromise the user, which is a local admin, on his account, on his computer, or they can do some privilege escalation on that machine. And by that, they can harvest the machine credentials, or they can scan for pre-created computer accounts with an empty password. You're probably asking yourself what pre-created computer accounts are. Say that you have the beautiful new Surface laptop that you wish to add to your domain. And by joining this laptop to your domain, a computer account object will be automatically created for you, for your laptop, in the Active Directory. But what if you have like dozens of servers that you wish to join to the domain and put them under certain OU for having specific group policy settings applied to them? For that, there are some tools for IT admins that some IT admins uses. And these tools have some flaws in it. These tools, some of these tools, create computer accounts with an empty password. So how the attackers can find these accounts? Well, first of all, we've seen such accounts in real environments, so you might have these accounts in your domains. And actually, such accounts are not really a security issue, because you can't really do anything with a computer account that doesn't belong to any security group or any high privileges. But we'll show you in this talk how attackers can abuse such account and get them high privileges on your domain. So in order to find such accounts, it's pretty simple for the attackers. They can scan with any domain user the list of computer accounts that belongs to that target domain using a simple ldap query, and then try to log on with each computer with an empty password. Another approach would be each computer account has a service principal name, meaning that you can use Kerberos to request a ticket for that account. And by that, the attackers can try to decrypt this ticket with an empty password hash. So eventually, once the attackers obtained at least one computer account, they can move forward to the next phase, which is the lateral movement phase. In the lateral movement phase, the attacker's goal would be to move laterally between different servers until they get at least the highest privileges they can get in this domain, which means domain admin privileges. And they do that by moving laterally between different servers. The most common technique to do that is by using, without having user credentials, is by using man-in-the-middle techniques or tools, such as Responder. And with these tools, the attackers can relay user authentications towards their target servers. The problem with these tools is that there is a mitigation for such a relay. By enforcing traffic to be signed, such as SMB signing, that the attackers, man-in-the-middle attacker, can't really sign the traffic, because the secret for signing is known only to the client and the server, the user session key in this case. Apparently, there is an issue with this mechanism. The user session key is actually based on the user's secret key, which is known only to the user and the domain controller, meaning that the server, in this case, would need to acquire this secret key, this user session key, from the domain controller via their secure channel. According to this CVE, there was a vulnerability, or there is a vulnerability, that attackers that owns a computer object, computer account in your domain, can actually open a secure channel on behalf of other servers. Meaning that if I've compromised, such as in the recon phase, if I've compromised one computer account in your domain, I can use this, the attackers can use this account to open a secure channel on behalf of their target sensitive server, and use this secure channel to obtain the user session key in order to encrypt the traffic to that server, and by that, move laterally to that sensitive server. So now that the attackers moved to the sensitive server, the next goal would be to have full domain dominance and persistence on their target domain. And the easiest way to do that is by having domain admin credentials. And according to this CV from last year, which was found by two guys from Preempt Security, Yoron Ziner, I think I saw him here in the crowd, attackers could relay authentications of domain admins to Windows ldap server, in our case, a domain controller, and relay the authentication to ldap-s protocol. By having an administrative session of ldap-s, attackers could do almost anything on the target domain. For example, they can create a domain admin account for themselves to use for their malicious activities and do whatever they want on the target domain. But creating a new domain admin account is something that attackers would try to avoid, because it might trigger alerts in some security solution that monitors exactly these activities on their target domain. So what the attackers would like to do is to have some technique which is much more stealthier. And this technique could be something that Marina will tell you all about it right now, is abusing a computer account, in our case, the pre-created computer account, which is a stale account that nobody uses, or create a new computer account, and by manipulating and changing few properties on that account, they'll have full persistence and domain dominance in their target domain. So Marina, please tell us all about this technique.
All right, so now we're at the persistence phase. So what do attackers have so far? Itai just showed you how we can gain an administrative ldap session with a domain controller. So this is the first thing that we have. The second thing that we need is the credentials of some computer account in the environment. So we can either use that compromised pre-created account that we found, or if we haven't been able to find any, we simply create a new computer account in Active Directory without joining the corresponding physical machine. Then we're going to use that administrative ldap session to manipulate the computer object in Active Directory. First thing that we're going to do is to trust the computer account for delegation. This will allow the computer account to request Kerberos service tickets on behalf of other users in the domain. Specifically, in our example, we will allow delegation to the KERB-TGT account. Now the computer account would be able to request ticket granting tickets on behalf of other users. Now, for the ones of you who are not familiar with Kerberos, a ticket granting ticket is equivalent to the user's credentials. So this ticket granting ticket can be used to request additional service tickets, and then those can be used to access domain resources with the privileges of other users. So bottom line, what we have here now is a computer account which can access any domain resource using the privileges of any other user in the domain. So this is a lot of power for a single computer account. And this is exactly why we needed that administrative ldap session, since only admins can grant other accounts the ability to perform delegation. So now we have a computer account which can be abused to gain high privileges at any stage. However, if someone scans the environment, it looks a bit suspicious. Why do we have a computer account that can delegate tickets to the KERB-TGT account? So if someone finds this, our computer account might get deleted. This is something, of course, attackers would like to avoid. So how can we solve this issue? In the last Black Hat, Will and Andy from SpectreOps showed how entire Active Directory objects can be hidden from plain sight. So they did this by manipulating the access control list of the object and adding an access control entry denying read privileges from anyone else on this specific object. So this is one thing that we could do. We can simply hide the computer account, and then no one would actually be able to see that it exists in the environment. However, here we're going to do something a bit different. We don't want to hide the computer account. We're OK with anyone seeing that the computer account exists. We just want to make it look like any other computer account in the environment, and so that it would not seem suspicious in any way. So what we need is to hide those incriminating attributes on the computer account. So we still need to manipulate the access control list, and we will add 2 access control entries on this computer account object. First thing is that we're going to deny read permission on the user account control attribute. This is the attribute that shows that the computer account is trusted for delegation. Second thing is we're going to deny read permissions on the MSDS allowed to delegate to attribute. This is the attribute which states that this computer account can delegate tickets to the KERB-TGT account. So now we have a computer account that can perform delegation to the KERB-TGT account, but no one can actually see that it has this ability. So let's recap what we have so far. We have a computer account, which first of all is not a member of any sensitive group, so it's not suspicious in that way. However, it can obtain an administrative ticket granting ticket at any time and use those high privileges to access any domain resource. And the best thing is that no one can actually see that this computer is trusted to perform this sort of delegation. So it looks like any other computer in the domain. Also, at this stage, attackers don't need to have control of a high-privileged account. They don't need the credentials of a domain admin. As long as they have the password of that computer account, they can regain high privileges at any time. Now, since there is no physical machine attached to this computer account, the password of this machine is not going to change. Since the group policy, which is applied on computer accounts and changes the password every 30 days by default, is initiated by the client machine, and since there's no client machine here, the password will simply not change. So as long as the attackers have that password, they can have administrative privileges at any time. Also, they can change the password periodically, just so it would not look like a stale account that someone might delete from the environment. So as you can see, we have a computer account with a lot of power that no one can see. So such a computer account can exist in an Active Directory environment for quite a while without someone actually noticing that there's something wrong with it. And now let's see a demo of everything that we've just described.
OK, so to the left, you have the attacker's machine. To the right, you have our domain environment, in this case, the user2, which is compromised. Just few. OK, we have the IP address of the client machine. Now, the attacker's goal is to relay authentication to the sensitive server that exists in this domain. And they try that without having machine account right now. OK, and this sensitive server is, as we'll see right now, have this mitigation enabled on. So we lure the user to try to access our server. And as we can see, by using the NTLM relay tool by in-packet, that this server requires signed traffic, meaning that the attack would not work. And we get status access denied for our activity. So the next step for the attackers would be to find a computer account that they can use in order to relay authentication to that server. So let's try that again. This is just show you how this works or not work when you don't have the actual computer accounts. So now we'll go back to our environment and try to find computer accounts with an empty password, pre-created computer accounts with an empty password. So this tool scans the environment for computer accounts and try to log on with each computer account with an empty password, and found one test PC, which has a default password of an empty password. This is the hash of an empty password. And now the attackers will give the NTLM relay tool the machine account to be used for opening the secure channel. And this machine account is the test PC in the target domain. And also provide the machine account password, which is the empty password in this case. This is the NTLM hashes. And the last parameter is to define which domain to open the secure channel to, which is this IP address. So, and the last step would be to define the target payload that will run once this exploit succeeds. And in this case, it's just a simple reverse shell, which will run on the target server. And this reverse shell would try to communicate back to our target attacker's machine. So we need to set up a listener in our machine using Meterpreter or Metasploit. We'll just set up a listener on TCP. It's a few lines of code. And once this all being set up, once our target user, our lured user, will try to access our machine, we'll relay his authentication towards the sensitive server. And hopefully, this would work, and we'll have, we could move laterally to that sensitive server. So now we have our listener set up. We can lure our user to access again our server. And this is exactly what the user will do. And now we should have compromised the sensitive server. As you can see here, we got the session in the interpreter, meaning that our exploit succeeded, and we moved laterally to the sensitive server. What we are doing right now is just having a stable session, not something much to talk about. But now, once we are done, we can have a shell on the target server, so you can run anything that you want on the sensitive server that we've just compromised. As you can see here, this is the IP address of the server that we try to exploit. OK, so the next step would be to change the attributes that Marina just discussed about in the test PC computer account to allow it to delegate to the SPN of the curb TGT. So right now, this test PC is a regular computer without any privileges. And now we'll run another relay on the sensitive server. But this relay, once it gets domain admin credentials or authentication, it will relay the authentication to the ldap-s server. This is our domain controller. And we specify it to change the attributes of the test PC computer account. So now we ran the NTLM relay on the target server. And once a domain admin will try to authenticate or to access the web server that we just compromised, in this case, try to look at my picture, we'll have domain admin privileges and ldap session with administrative rights, and we managed to change attributes on that computer account. So having a look at the delegation, now this computer account can delegate to any service. And in this case, we've asked it to, we changed it to delegate to curb TGT, as you can see here right now. In a moment, OK? So this machine can delegate on behalf of any user to the curb TGT, meaning that you can ask this machine to have tickets on behalf of domain admin and use these privileges to access whatever you want. And the next step is to hide the things that we did by manipulating the access control list of that object. And this is why you can't see right now anything. It's like we didn't do anything on that object. The curb TGT is hidden. And if you'll have a look at the access control list of that object, you will see 2 denied permissions to everyone on the user access control read, read user account control, and deny read on MSTS allowed to delegate to. So we have a computer account which is super sensitive and have the ability to compromise your domain immediately, but no one can see that. So now Marina will show you how we can mitigate from such attack. Please, Marina.
All right, so now let's discuss some of the mitigations that we have. So for the reconnaissance phase, we had those pre-created computer accounts that we do not want to exist in our environment. If attackers can scan for those accounts, so can defenders. We can simply request service tickets for all the machines in the environment. We can do this since computer accounts by default have a service principal name. Try to decrypt it with a hash of an empty or an easy password. And if we're successful, we need to either delete the machine from our Active Directory environment or join the corresponding physical machine, which would then generate a complex password for this computer account. Also, in order to detect someone which might be actively scanning our environment to find such accounts, we need to monitor both massive failed logon operations and massive ticket retrievals from a single domain machine, which is also very useful to detect Kerberoasting activities. Now, for the lateral movement phase that we showed, all we need to do is to just patch your environments. All right, now for the persistence. So here we had a few issues that we had to address. We have the delegation and we have the visibility. So all we need to do for the delegation phase is monitor the accounts that are trusted to perform delegation and monitor to which service principal names those accounts are able to delegate to, meaning to which services is the account able to request service tickets on behalf of other users. Of course, you should not have a computer account which can perform delegation to the KRB TGT in your environment. Also, every Active Directory object has a checkbox which states this account is sensitive and cannot be delegated. And it means that even if you have an account that is trusted for delegation, it would not be able to request service tickets on behalf of those sensitive users. So if such an account gets compromised, it would not be able to compromise the credentials and the privileges of those sensitive accounts. So we recommend turning this on for the high privileged accounts in your environment. Now, for the visibility problem, we had two issues. We could hide specific attributes on the object, or we could hide entire objects from everyone else. So we have solutions for both of those, for both of those problems. So for the hidden attributes, all we need to do is simply monitor the access control list of the object. In our case, we just hid the attributes that are related to delegation, and no one could see that the computer account is trusted to delegate tickets to the care PGT account. So you actually need to monitor the access control list of all the objects in your environment. Just monitoring the high privileged accounts would not be enough, since, as you saw, we simply changed the access control list of a machine that is not actually connected to the environment and could obtain persistence by using that simple account. Now for the hidden objects problems, and this is a bit trickier. If you can't see the object, you can't read the access control list, and you can't see that there is an entry denying you from seeing that object. So how can we overcome this obstacle? First of all, you might not see the account in Active Directory, but you can still see any traffic that it generates. So if you have some monitoring solution which monitors network traffic, it can detect such accounts. Another way to detect those accounts is by using a Windows API called LSA lookup seeds. So it does the following. Given a seed, it can return the corresponding account name to this seed in the environment. Now, the good thing about this API is that there is no access check required to perform the mapping between the seed and the account name. So even if there's an account in Active Directory which I cannot see, theoretically, if I know the seed of that account, I can still perform an LSA lookup seeds operation on that seed and get the corresponding account name, even though I'm not allowed to read the properties of that account. Well, obviously, if I can't see the account, I don't know what the seed is, and I can't actually perform this. However, there is a way to get a list of all the accounts that I'm denied from seeing. And this is how we do it. We're going to scan all the seeds in the environment, starting from the first one up until the one the domain controller just handed out, and we'll perform an LSA lookup seeds operation on each and every one of them. So this would give us a list of all the objects that exist in Active Directory, since the access control list does not apply here. Also, we are going to perform an ldap query to get all the objects from Active Directory. So this would give us the objects that we can actually see. Now, all we need to do is compare between the results. If there was some account that was resolved successfully by using the LSA lookup seeds API, but we did not see in the ldap query results, this means that those are the accounts that we do not have the permissions to see. So there is a script which does just what I described, which can be found in the link on the slide. So just to sum up, as you can see, user accounts are not the only ones which can cause damage to your environment. Computer accounts can be just as easily abused, and sometimes it might be easier to fly under the radar by abusing those accounts, since probably in most environments, they're not monitored as well as those high-privileged administrative accounts. So when you're monitoring the behavior of the accounts in your environment, make sure you don't leave out the computer accounts. Thanks.